Hello. Today we're going to be talking about solving a system of inequalities. And last time we talked about solving just one linear inequality, but now we have two. And so you can see I have two inequalities up here, and there's this implied word in the middle that is and. So we're going to graph them just like we did, but now we're going to do it and figure out where they overlap. So it has to be true for both of them. So let's go ahead and do this. So if I want to graph y is greater than 2x minus 5. Now the great thing is y is already by itself here, so I'm good to go. So I'm going to go down to negative 5 on the y-axis, and I'll start there. And then do my slope of up 2 over 1. And I can also go down 2 and left 1. And you can see how, because it is simply greater than, I'm going to have a dashed line. There we are. And again, because we're greater than, that means we would shade above this line. So I'm going to put little arrows there to let me know that's the direction I'm going to shade. Okay, let's do the next one. So if I wanted to graph y is less than negative x plus 2. I'm writing this in blue so you know that this is the blue line. So we start at 2 on the y-axis, and I have a slope of negative 1, so the down 1 and right 1. I can do this a whole bunch of times. I can also go up 1, left 1, a whole bunch of times. There we are. And again, we're simply less than, so we're going to just have a dashed line. And there we are. And we're less than now, so we're going to shade below this line. So because we have two lines intersecting, we have 4 different regions that this has been separated into, and we want to find that one region where both lines are pointing. So that's this little one right here, this one here on the left. We can keep going all the way out forever and ever. Okay, and that's what this looks like. So again, it has to be true for both, and that's the location where it is. Okay, so let's try another one. And luckily for us, it is a story problem. Ronald runs a mowing service. He makes $10 for a small lawn and $25 for a big lawn. He wants to make at least $150 each week. However, he can only work up to 15 hours each week. Work up to 15 hours each week. A small lawn will take 1 hour to mow. A big lawn takes 2 hours. Write and graph a system of inequalities to show how many of each lawn type Ronald should work. Okay, so we have two things that we don't know here. How many big lawns, B for big lawns, that Ronald should work, and S for small lawns. Use this to write some inequalities for this information. So I have first the money. It's $25 per big lawn, plus we'll get $10 per small lawn, and we want that to be at least $150 per week. So the $150 should be the low mark, so we need this to be greater than or equal to 150. Okay, we have a second inequality now, and it's going to take 2 hours per big lawn to mow, plus it'll take him 1 hour per small lawn to mow, and that needs to be, he can only work up to 15, so 15 is the highest it can be, so this one's going to be less than or equal to 15. Now to graph these, we need to get a variable by itself, and let's get S alone. So this will be up here, essentially our y-axis will be small lawns, and then our x-axis will be big lawns. All right, so if I were to start getting this one alone up here, I'm going to subtract 25b. So 10s is greater than or equal to negative 25b plus 150. And then we divide by 10. And so S is greater than or equal to Negative 25 over 10 simplifies into negative 5 halves times b plus 15. Okay, and then the other one, if I get that alone, I'm basically just going to subtract 2b, and I come up with s is less than or equal to negative 2b plus 15. All right, so my y-intercept are for both of them is 15, so I certainly need to scale this up to 15, and I'll simply count by, let's go by 3, so 3, 6, 9, 12, 15, 3, 6, 9, 12, 15. Okay, and I can do the same thing over here. 3, 6, 9, 12, 15. 12, 15. There we are. Okay. For the blue inequality, you start at 15 for your s-intercept in this case, and you go down 5 over 2, and I can simply count this way down 5 over 2 here. And we're going to have a, because it is a equal to, it is greater than or equal to, we'll have a solid line here between those two. And then for my purple inequality, we'll start at 15 again, and this time we're going to go down 2 over 1, down 2 over 1, and that would take me down here. And again, it is now less than or equal to, so this one is also solid. Okay, we have a couple inequalities that we haven't really talked about yet, but that do exist here, because I know that the number of small lawns that I need to do has to be greater than or equal to 0. I can't do less than 0 small lawns, for the same reason I can't do less than 0 big lawns. So I'm also going to have this inequality. This one is for b is greater than 0, and this one would send me this way. And this one would be for s is greater than or equal to 0, and this one would send me above the x-axis. The purple line being less than or equal to is going to send me that way, while the blue line being greater than or equal to is going to send me that way. So where do we shade? The one spot where they all work is right here in the middle, between them. Now it appears that I can get this ordered pair here of 6, 3 as a solution. So that would mean that I am allowed to do 6 big lawns and 3 small lawns. Let's check to see if that works. If I do 25 times 6 plus 10 times 3, is that actually going to be greater than or equal to 150? Well, 25 times 6, that's 150. 10 times 3 is 30. So certainly I'm going to get $180 that week. That'll be fine for what I wanted. And if do I have enough time to do that? So 6 big lawns times 2 hours plus 3 small lawns times 1 hour, is that actually going to be less than or equal to the 15? So I get 12 plus 3, which is less than or equal to 15. It's the same thing. So that one would work. So 6, 3 would be one solution. And that's basically how you would find the others. You see anything shaded in red, you would expect it to be able to work for Ronald and his lawn service. And we are done.